So sometimes the absolute fastest way to move massive amounts of data to the cloud is to, well, literally load it onto a truck and drive it down the highway.
Right, which sounds completely backwards, but it is actually true.
It really is. Welcome to this deep dive into Google Distributed Cloud and Edge infrastructure. For you listening, our mission today is exploring how we overcome the physical limits of network latency and bandwidth, basically by, ripping the cloud out of the data center and bringing it directly to the data source. Okay, let's unpack this. Cloud computing is incredibly powerful, but we are still bound by the literal laws of physics, right?
Yeah, specifically the speed of light.
Yeah.
I mean, we are so used to treating the cloud like this infinite weightless resource. But if you are running a smart factory or, say, life-saving clinical systems in a hospital, you just cannot afford the network latency of sending data round trip to a massive server farm that is, 3 states away.
Oh, absolutely not. You need guaranteed sub-10 millisecond response times for operations like that.
Exactly. And since we cannot break the speed of light, Google's solution is GDC Connected. It basically drops Google's managed hardware and software directly into your own local data center.
Okay, so it is kind of like, think of it like hiring a world-class Google chef, but having them actually cook in your specific kitchen so the meal is served to you instantly.
That is a great analogy, actually. Yeah. And the really crucial mechanism here is that this local hardware remains continuously tethered to Google Cloud's management control plane. So your engineering team doesn't have to learn some brand new offline deployment strategy.
Yeah, wait, so they just use the exact same tools.
Right, exactly. They can push a container update via GKE exactly like they always do in the standard GCP console. But the actual execution of that workload, well, it happens entirely on the local iron.
Oh, wow. Okay. So it is a lot like human reflexes. Like if you touch a hot stove, your hand pulls away instantly because the processing happens locally in your spinal cord. You don't wait for the signal to travel all the way up to your brain.
Yes, that is exactly it. GDC Connected gives your local network that instant reflex for things like Vertex AI inference. And then the central cloud control plane just acts as the brain managing the broader system. Plus, it elegantly solves strict data residency requirements.
Right, for places with really strict local laws.
Yeah, like if local laws dictate sensitive clinical data cannot legally leave a hospital's physical premises,
Yeah.
you just process it locally. You get the cloud benefits while remaining fully compliant.
Sure, and running cloud software in a pristine hospital server room makes total sense. But here is where it gets really interesting. What if you don't have a climate-controlled data center at all? Like, data is constantly generated in environments that are super hostile to traditional servers. A dusty manufacturing floor, a retail backroom, or even just a vibrating delivery truck.
Yeah, that is the exact use case for GDC Edge appliances. These are highly ruggedized, compact, and super power-efficient nodes. They are specifically engineered for those harsh or space-constrained environments.
But wait, how is it actually still cloud computing if it is sitting in the back of a moving delivery truck without an internet connection? Doesn't the lack of connectivity just totally break that unified management plane you mentioned?
What is fascinating here is that it bridges the gap through local buffering.
Local buffering.
Yeah, so the Edge appliance handles the immediate, localized AI processing entirely offline. Like, say, analyzing live video feeds to track inventory on that specific truck.
Okay, so it is doing all the heavy lifting locally.
Exactly. And while it is doing that, it locally buffers all its observability logs and security telemetry. Then, the moment that truck pulls into a depot and hits Wi-Fi, it seamlessly syncs that buffered data back to Google's centralized stack.
Oh, that is so smart. So the IT team at headquarters can still manage security policies and logging just as if it were a traditional cloud resource.
Yes, you get the edge execution, but you keep the unified governance.
Okay, so we have solved distance and harsh environments. But if we connect this to the bigger picture, what about sheer volume? I imagine a major bottleneck is the initial migration. You cannot just push petabytes of legacy factory data over a regular internet connection to get started.
No, you really can't. Moving petabytes over a standard network could take months, and it would incur massive egress costs. That is why Google uses Transfer Appliances.
Which are what, exactly?
They are these high-capacity, tamper-resistant physical storage devices meant for offline migration. You load your data onto them locally and physically ship the hardware back to a Google data center.
Wait, really? Sending physical hard drives through the mail? That sounds like a massive security liability compared to a secure network tunnel.
Well, would be if it weren't for customer-managed encryption keys, or CMEK. Yeah, you encrypt the data locally on the appliance before it ever even leaves your loading dock. And because you hold the keys, not Google, and definitely not the shipping company, even if that physical hardware is intercepted somehow, the drives are effectively just useless bricks.
Wow. Which brings us right back to the truck on the highway from the beginning. For multi-petabyte migrations, a delivery truck full of hard drives is literally faster than the internet. It turns a huge bandwidth bottleneck into a simple logistics task.
Exactly. By completely bypassing the internet, you bypass the latency and the bandwidth limits all at once.
So what does this all mean? The core takeaway for you listening is that the cloud is no longer just a remote destination. It is a flexible infrastructure model that physically meets you right where your data is generated.
Right. It adapts to the physical reality of the business.
Exactly. But it leaves us with an interesting thought to chew on. With edge appliances putting AI inference directly into remote factories and moving delivery fleets, how will this invisible, localized, everywhere cloud permanently change the way physical, offline industries operate day to day? Keep that in mind next time you check your tracking on a package.